Humidity. An inspector should measure the humidity when performing an examination of the building. It's not required. It is to your discretion. High humidity in a building can lead to mold growth, so humidity gauges are very useful. When a high humidity level is measured inside a particular area of a room or building, in a building, the measurement may indicate hidden mold growth. Further evaluation is needed when high humidity levels are measured and mold growth is not visible. There are measurement tools that measure both humidity and air temperature. Those tools typically have an infrared, non-invasive infrared, non-contact temperature device to take measurements. Digital cameras. I'm a big fan of digital cameras. I've been using digital cameras since 95, 96 during my home inspections. Digital cameras should be used to take pictures of all the sampled areas and the condition of the property as it was on the day of the inspection and the condition of the outdoor environment. A digital picture should be taken of all the areas of concern: moisture intrusion, water damage, musty odors, apparent mold growth, conditions conducive to mold growth, and any other system or component of the building that may be having problems and contributing to moisture or mold growth. Other inspection tools and equipment. Mask and a respirator. If you touch mold, you're disturbing it, and you may be putting mold spores in the air. If you're in a crawl space, who knows what's in the dark crawl space? Get a respirator. The N95 ones are, in my opinion, okay. You need at least a lower face respirator. Full face mask respirator protects your lungs and your eyes. Get a work suit to go into the crawl spaces and attic spaces. Have lots of pockets in your work suit so you can carry your moisture meter, your humidity and temperature gauges, your digital camera, your screwdriver, poker, flashlight. Get knee pads. Use some crawl gear if you're going into the crawl space. Protective gloves, cloth or latex, so that if you touch mold on the floor or on the dirt or on the carpeting, it's not absorbed into your body. Duct tape, especially for remediation. People like to duct tape their feet in their sleeves to their gloves. A hard hat, or like a crawl gear hard hat that looks like a baseball cap, or at least something to protect your head from dust. You could brush up against the bottom of a joist that has mold growth on it, and now you are a transporter of this mold growth to the areas in which you go after you get contaminated. Shoe covers. My inspection company, we used to wear slippers, indoor slippers. There are shoes that kind of look like hybrids of shoes and slippers. They're soft. Use indoor shoes only and exterior outdoor shoes only, two separate shoes, or you can put some covers over them. So protect not only the building's floor, but also to stop the transfer of contamination. Laser pointers. A lot of home inspectors use laser pointers so that they can, let's say, come out of a crawl space, sitting in the crawl space opening, and speak to their client, but communicate clearly what they're looking at 20 feet in to the crawl space. A laser pointer is really good for communication. Headlight. I used headlights and headlamps all the time to go into crawl spaces. That frees my hands. And when I went into the attic spaces, especially when there wasn't a whole lot of flooring or like the truss components to grab onto, and you know there wasn't any flooring and you're trying to balance yourself, headlamp is really great. Frees your hands. A non-contact voltage detector beeper instrument that goes if it detects voltage. Doesn't help you detect moisture, but it keeps you safe because you will be put in those positions where some electrical wires may be hazardous to your health. A work light. If you're going to use a work light in any kind of damp area, like a garage, detached garage with a dirt floor, a crawl space, make sure you have GFCI protection. A carpet for cleanliness. When you go into the attic space, what I did was I bought a sheet that looked like a picnic cloth that you lay down, you know, red and white squares. And I put it down, then I put my ladder down, and I went through the attic access. And if any insulation or other materials fell down, I would just gather it up. And use a carpet for placing right in front of the crawl space access opening. So when you come out of the crawl space access opening, you can brush your feet, brush it off a little bit, put down your tools, and you're not damaging anything. Some crawl space accesses are through the floor, not through a wall, an interior wall, or a perimeter wall, exterior wall. They could be inside the closet. So when you come out, you're inside someone's closet, inside someone's home. You have to be really clean. Laying down a piece of carpet is really great idea. And a little thing that I do that is a great tool. It's a marketing tool, really, but it's also for protecting yourself. It's your business card. Leave your business card somewhere. Kitchen table, especially if the house is unoccupied or, worse yet, vacant, and you've come to the inspection early and you're in the crawl space or you're in the attic space or the space where not a lot of people go. Leave your card, or a note is even better. I'm in the crawl space. You don't want to surprise anybody doing your mold inspection visual examination. So leave your card to tell people you're somewhere, and you'll be safe. It's also good marketing too. A measuring tape. You need a measuring tape in order to evaluate the extent of the contamination that's apparent. There may be areas of hidden mold growth, but what's available to your eyes, you should measure so that you can categorize it, small, medium, or large. Personal protection equipment. Let's go over PPE and respirators. It's very important. We're dealing with airborne mold spores. So respirators and protecting yourself is essential to understand. We learned about the inspection tools and the equipment. Now let's go over some PPE and respirators. Mold inspectors are subject to exposure to a wide variety of hazards, including insects, wildlife, construction debris, abrasions, dust, asbestos, lead, bioaerosols, mold spores. Since mold spores can enter the inspector's body through touch, ingestion, and inhalation, PPE is very important to an inspector. PPE stands for personal protection equipment or personal protective equipment. The use of personal protective equipment should be considered during a mold inspection. Prior to a mold inspection, actually. PPE protects against the hazards of working inside mold-contaminated areas of a building by limiting exposure. It's needed when mold is disturbed and likely to become airborne during a surface sampling. It may be unavoidable to have mold spores released into the air during the inspection or remediation of mold. Airborne spores can pose a health threat when they're inhaled, or if they're touched and ingested. Diseases or allergic reactions to mold may manifest when mold spores enter through the respiratory system. Therefore, a respirator for a mold inspector is commonly used. The primary function of PPE is to avoid inhaling mold and mold spores and to avoid mold contact with the skin and eyes. There are many different types of respirators. The selection of respirator depends upon the mold inspection scope, contamination conditions, and the requirements of any remediation work that's going to be done if you're doing remedial work or involved in that. Some mold inspectors come during the remediation process and after the remediation process to inspect how clean the area is. Attention to the health of the inspectors, workers, and the occupants of the building are essential at all times. Care must be taken to ensure everyone's safety. To ensure a safe work environment for everyone performing inspections and remediation work, efforts to protect against exposure to mold contamination must be taken. A mold-contaminated building can be a dangerous place in which to work. Good work practices and safety procedures must be followed to prevent or effectively limit mold exposure. Let's talk about hand protection. There are many types of gloves available for inspections and remediation work. Dr. Shane demonstrated that in this course, he demonstrated that you don't necessarily need to be wearing latex gloves if you are careful with your procedures and your habits during a mold sampling. There are gloves that are chemical resistant, cotton, canvas, puncture resistant, disposable latex and leather. Thick work gloves are best when the remediation people are working. Rubber gloves can protect from electrical hazards. Leather gloves can protect from abrasion and cuts. For mold inspections, disposable latex gloves are recommended but are not necessary. A mold sampling can be performed according to the mold sampling protocols without wearing gloves. Eye protection should be worn during an inspection where mold is visually evident, or at least it should be available. Eye protection should be available. Airborne mold spores, particles, and materials can enter the body through the eye. Goggles, safety glasses, and eye shields are readily available. Safety glasses or goggles that have open holes on the sides are really not efficient, not acceptable. A full face respirator has eye protection. A lower face respirator doesn't. It's important to choose the proper type of eye protection since most work-related eye injuries are related to wearing the incorrect type of protection. Head protection. You may choose to wear a hard hat, a helmet of some kind. During a mold inspection, a visual examination, I rarely have the need to wear a hard hat, although there are many helmets available, Class A, B, C. That's usually for mold remediation work. Protective clothing is recommended for underfloor crawl spaces and attic spaces and some other areas that you may be involved with during a building inspection. Protective clothing is recommended for medium and large remediation jobs for sure. Protective clothing prevents the transfer and spread of mold to other clothing and eliminates skin contact with mold, which is really essential to understand when you're doing an underfloor crawl space inspection and remediation work. Respirators. The human respiratory system can only endure a small amount of exposure to toxic gases, fumes, and particles. Some inhaled chemicals can destroy portions of the lungs. Chemicals in the lungs can be absorbed into the bloodstream where tissues and organs can then be affected. Respirators can filter gases, vapors, and particles in the air. They're very important. In a work area, the Occupational Safety and Health Administration, OSHA, regulates the use of respirators. OSHA states that all respirators must be 1. Approved, 2. Color coordinated according to the known hazards, and 3. Individually fitted. Respiratory protection should be used when the concentration of airborne substances exceed a specific exposure limit. And there are several exposure limits that can be used to determine the requirement of a respirator. There are no mold exposure limits for inspectors defined by the 3 major national groups, OSHA, NIOSH, and ACGIH. It is up to the mold inspector to decide when, where, and what type of respirator to use, if at all. In a work environment, OSHA requires a few things: a written standard operating procedure governing respirators. The respirators are selected based upon the hazards to which the worker will be exposed. The workers shall be trained on how to use the respirator properly. Respirators shall be regularly cleaned, maintained, and inspected. And the work area should be inspected to maintain good working conditions. The selection of a proper respirator depends upon the nature of the hazards, the nature of the work or activity in the hazardous area, the location of the hazardous area in relation to safe areas having clean, breathable air, the length of time of exposures to those hazards, the effectiveness of the respirator, and the individual fit of the respirators. There are different types of respirators. Filtering disposable mask. A particulate N95 respirator is an air purifying respirator used to provide protection in dusty, non-oil-based environments like sanding, bagging, or grinding. It is lightweight in construction and has a crimpable nose clip to provide a customized fit, not very tight. It's really not recommended for mold inspectors. A lower face or half mask respirator has a face sealing flange or chin holder, which really doesn't work when you have this facial hair. It has a head harness. The cartridges are disposable. The filters are job hazard specific, and they're readily available and easy to replace, although it doesn't provide full face and eye protection. A full face respirator has dual cartridge attachments. There's a full field of vision provided. It has a sealing flange and a head harness. It provides the greatest protection. This mask is best for mold inspection work and remediation work. A mold inspector, particularly inside a crawl space, should wear a respirator. Be safe. Be safe with good practices and good habits. Safety is very important for all types of jobs, including inspections and remediation work. Take the proper precautions to keep your work environment safe. Train yourself in safety procedures. Be attentive to other people's health and wear protective equipment. Hypotheses. Let's talk about developing hypotheses. And we need to know the different types of hypotheses to develop, because a mold inspector should develop hypotheses, a set of hypotheses, prior to performing any type of mold inspection. There are 5 different types, but you may make more. There's the null hypothesis. There's the damaged building hypothesis. There's the aesthetic effects hypothesis. There's the health effects hypothesis. And there is the that which is visible is mold hypothesis. A similar approach to gaining knowledge is shared by all scientific disciplines. The scientific method involves observing empirical evidence and drawing references from it. One school of thought holds that sampling can only disprove a hypothesis, and an inspector can never prove a cause and effect relationship. An alternative understanding of the basis of scientific knowledge is that all inspectors begin with a set of prior beliefs and assumptions. That's what I do during a mold and home inspection. I go in assuming that there's something wrong, and I go in trying to find it. That puts me at a slight bias, but that's how I start my inspections. For example, an inspector may begin an examination of a building with an underlying assumption that there exists a roof leak that has been undiscovered in the building. Progress is made as hypotheses based upon prior beliefs are tested by collecting empirical evidence or data, which either supports or refutes the hypothesis that the roof is leaking. Before any sampling takes place, an inspector should develop a set of hypotheses that address the concerns of the inspector's client. A hypothesis is a proposition set forth as an explanation for the specific observation or condition experienced. A hypothesis is often used to guide the inspection, a working hypothesis, and can be accepted as highly probable in the light of established facts. Hypotheses concerning the suspected role of fungal or mold exposure on adverse effects should be developed before any mold sampling or examination takes place. The mold inspector and client should agree to the hypotheses and agree upon how they should be addressed through visual examination and mold sampling. The inspector needs to gather information, develop hypotheses, test these hypotheses, and make recommendations based upon all available information that's gathered. The mold inspector has to gather information. Gathering information involves asking the client about their concerns about mold, the reasons why they are requesting a mold inspection, and what relevant information they intend to receive from that inspection. Setting expectations with the client is part of this information gathering. There are generally three types of concerns clients may express about mold growth in a building. One, a client is concerned about the potential health effects of mold exposure. Two, a client is concerned about the effect of mold contamination on the structural integrity of the building. Damaged hypothesis. Third concern, a client could be concerned about the negative aesthetic effects a fungi can produce, both visually and on the human olfactory systems. These three here. Although the issue of whether exposure to indoor fungi causes adverse health effects is controversial, there's no doubt that a seriously mold-contaminated building can suffer structural damage, and that a foul-smelling, fungus-filled building is aesthetically unpleasing. Controversies about health effects aside, the latter two concerns are sufficient to merit a complete mold inspection and remediation when an environment is found to have mold contamination. People who have concerns about structural damage or the aesthetic effects of indoor fungi should seek the services of a certified mold inspector like yourself. People who have concerns about health effects of mold exposure should seek the counsel of a healthcare professional. There are generally 8 questions that can be answered by a visual examination and mold sampling of a building. 1. Is there water intrusion into the building? 2. Are there water damaged components in the building? 3. Are there musty, moldy odors in the building? 4. Is there any visible apparent mold? 5. Is that which is visible actually mold? 6. Are there indications of hidden mold growth? 7. Are there conditions conducive to mold growth? And 8. What should be done if mold growth is discovered? To address these concerns, hypotheses, questions accurately, a visual examination must be performed to a standard. Mold samples must be taken according to procedures. Laboratory analysis must be included, and proper documentation must be made. Proper collection, handling, and documentation of a mold sample is required for a conclusive, credible report, and all inspection procedures should be followed carefully and precisely, because poor handling can lead to mistakes, errors, and liability exposure. Hypotheses. Let's develop some hypotheses. There are generally 4 main hypotheses about fungi in an indoor environment that can be developed by an inspector and their client. One, there's no mold growth in the building. That's the null hypothesis. Health is being affected by mold exposure. Health affected hypothesis. This one here. The third one is structural damage is caused by mold growth in the building. That's the damaged building hypothesis. And the aesthetic hypothesis is that musty odor indicates mold growth. Talk about this one later. Null hypothesis. Ideally, an inspector should approach a mold inspection without bias towards finding mold. It is reasonable to assume that a building does not have a mold growth problem. If the client does not have any concerns, then the inspector should assume that there are no mold growth problems in the building. That's the null hypothesis. The inspector should approach the mold inspection with an unbiased opinion without any presumption of mold problem existing in the building. An assumption that there is no mold growth in the building should be made prior to performing a mold inspection. And in that way, if an actual mold problem is found at the building, it will be unexpected. Legally, it's a stronger argument that a mold inspector initiated a mold inspection without bias, without a presumption that a mold problem existed in a building. You've heard the saying, you go in there finding something, you're going to find it. If your client does not express a particular concern about a mold problem in the building, then make the null hypothesis. Assume that there is no mold in the building prior to performing the inspection. Damaged building hypothesis. Very easy. If damage to the building were suspected to be caused by fungal contamination, then a reasonable hypothesis would be that mold is present and harming the building. Aesthetic hypothesis is that stains and odors are caused by the presence of mold. Health affected hypothesis. Health effects of indoor mold exposure may depend upon the types of mold that are in the building. Under certain circumstances, such as when litigation is involved, the source of the mold is unclear or health concerns are a problem, you may consider sampling as a relevant part of your evaluation. Concerns about health effects are more complicated because they involved a chain of hypotheses. Mold has to be present. The affected person must be exposed to mold. The affected person must be sensitive to the mold exposure, and the exposure must cause the symptoms. Since that chain of hypotheses are very difficult, if not impossible, to prove during a mold inspection, then an inspector should apply the statements and conclusions made by credible sources, health professionals, the EPA, state health departments, indoor air quality associations, and others in the industry, who comment upon mold standards and guidelines in relation to health effects. An inspector should make good use of them as relevant, suitable, or pertinent in interpreting laboratory results and making recommendations to their clients. The purpose of a non-invasive visual examination is to report areas of concern: moisture intrusion, water damage, musty odors, apparent mold growth, and conditions conducive to mold growth. Determination of patient sensitivity to mold and the assessment of the relationship between that sensitivity and symptoms should be determined by a health care professional. It's not the inspector's responsibility to relate mold in the building to their client's health. Let's go to this one here. That which is visible as mold hypothesis. According to the EPA, Environmental Protection Agency, quote, in most cases, if visible mold is present, sampling is unnecessary. An inspector may object to that statement because of the assumption that what is present is actually mold. No one knows. There may be many inspectors who are comfortable in making that assumption. Fine. Quote, that which is visible as mold is a statement based upon an assumption. Apparent mold growth cannot be confirmed by a visual examination only. The only way to actually know what is visible is actually mold is through sampling. If neither you nor your client need to confirm that what you see is actually mold, you don't need to sample, you're done. However, there may be others who are looking at your report and seeing that you said what is visible is mold, and they may be affected by the findings of that report, may request proof or validation that what you saw visually was in fact mold. How did you make that determination? The term visible mold applies to what appears only on the surface, not to what is borne out by professional examination, scientific sampling, and confirmation by laboratory analysis. The use of the term visible mold should not be used in reference to actual mold growth. The term visible apparent mold is accurate, the word apparent. Don't guess. It's an inspector's due diligence to act and perform with care and accuracy. Reporting the presence of visible mold for a professional inspector should be based upon fact or evidence rather than possibly inaccurate assumptions about your visual interpretation of surface appearances. Not everything that looks like mold is actually mold. Paint on the back side of drywall or wood with paint splattering may look like mold. Alkaline crystals on soil or alkaline crystals on concrete walls of a foundation may look like mold, but they're not. Carpet stains may also look like mold. Spider webs, fine dust, paint spray, dried mud, water stains may all give the appearance of mold growth. The inspector who reports the existence of mold growth based upon the discovery of something that appears to look moldy is likely in error. It may be mold, it may not. Error comes with guessing. Don't guess. Most microbiology laboratories need only a little of the suspected mold on a clear strip of sticky tape to determine, using a microscope, whether it is actually mold or something that looks like mold. It's very easy to sample. Relatively inexpensive. Sampling may locate the source of the mold contamination, identify some of the mold species present, and differentiate between mold and soot or dirt. Test your hypotheses. Test the hypotheses by collecting and analyzing all relevant information about the building, its systems and components, by performing a non-invasive visual examination and taking multiple mold samples. The mold sampling should be in alignment with the client's concerns about mold. In an attempt to conserve time, money, and resources, the amount, the type, the location of the samples should directly address the hypotheses that have been developed by the inspector and the client. Don't take 1 billion samples and waste your client's money if all you need are 4. Make recommendations. After finding apparent mold growth, the goal is to confirm that it is in fact mold. To report mold growth with care and accuracy is through sampling by a certified inspector and analysis by a certified laboratory. Sampling should be conducted if mold is inspected. After confirming mold growth at high or elevated concentration levels inside a building, then cleaning up and/or removal of the mold growth and contaminated building materials should be recommended. And there are several resources to refer to when making mold remediation recommendations. Later in the course, we'll be going over some remediation. And in your course materials, a lot of it is outlined. Let's do an example of a hypothesis. The following is an example of a hypothesis an inspector can use as a guide. After speaking with the inspector's client, the inspector develops a null hypothesis stating there is no mold growth at the building that could affect the health of the occupants, cause structural damage, or produce odors. And there are no conditions conducive to mold growth. While performing the non-invasive visual examination of the building, the inspector finds visible apparent mold growth on the drywall of a non-load-bearing wall in the basement near the hot water source. Additional assumptions or additional hypotheses can be made by the inspector then, because something unexpected has been discovered. The apparent mold growth is in fact actual mold growth. Enough moisture exists in this area of the building to support the mold growth. Another hypothesis could be mold spores from this growth area are floating in the air, the breathing zone of the rooms in which the building occupants dwell, and the mold may affect the health of those exposed. Let's say that the inspector determines that further evaluation is needed in order to find the source of the moisture in the building that is supporting the apparent mold growth. The use of a moisture meter or other device can provide an objective indication of the amount of moisture in a building material. A closer examination of the area and the use of a moisture meter by the inspector results in discovering significant moisture coming from a dripping temperature and pressure relief valve of the hot water tank. The wall material is discovered to be wicking up moisture from the floor where the water drip is located. The inspector determines that a surface sampling is needed to confirm the existence of actual mold growth. The inspector determines that the air sampling is needed to address the concern that mold spores may be floating in the air and affecting the health of those exposed. A surface sampling of the apparent mold growth in the area is taken. The result of the surface mold sampling confirms that the visible apparent mold is in fact actual microbial growth mold. Ultimately, the presence of microbial growth, which is only possible if water is available, provides evidence that sufficient moisture was present. Multiple air samples are taken. The biological agents of interest are fungal allergens, but detection of fungal spores is often used to indicate allergen presence. The results of the air sampling confirms that there are elevated levels of mold spores in the air in the basement as compared with the control samples taken outside the building. So, the initial hypothesis that there is no mold growth at the building that could affect the occupant's health, cause structural damage, or produce odors, and there are no conditions conducive to mold growth, was disproved and found to be false. The evidence outlined in support of the three assumptions or additional hypotheses that the apparent mold growth is in fact actual mold growth, enough moisture exists to support mold growth, and mold spores are floating in the air, are sufficient to conclude that the source of the excessive moisture in the basement should be corrected and the water damaged or mold contaminated wall material should be replaced. The fourth assumption about health should not be directly commented upon by the mold inspector. A recommendation to consult with a healthcare professional should be made in relation to connecting mold exposure to your client's health effects. There was, in fact, moisture intrusion and mold growth in the building of this example. And since there was an elevated concentration of mold spores measured in the air, the potential for health effects caused by mold exposure exists in the building. Information about health effects related to mold exposure and recommendations to remediate the mold problem in the building are provided to the client in the mold inspection report. That's a great example of developing and testing hypothesis. Another example of an hypothesis: an inspector makes the hypothesis that there is not a mold growth problem inside the HVAC ductwork system. Null hypothesis. Air samples are taken before and after the HVAC system is turned on. Air samples show a significantly lower concentration of mold spores in the air before the HVAC system was turned on than when after it was turned on and operated for 15 minutes. The sampling results may be convincing that there is a mold growth problem somewhere inside the ductwork, and mold spores are being distributed and circulated throughout the building when the HVAC system is turned on. If you take a look at your course material document, we see that in section 11 we go over a lot of the sampling devices. There's the bioaerosol impaction sampler. This is a device that is demonstrated by Dr. Shane in this mold inspection training online video course. There's the airborne particle counter. These are handheld, battery-operated instruments that also measure temperature and relative humidity. This device does not produce a sample that requires laboratory analysis. It only identifies the size of particles that are airborne. And this can be very helpful if you are trying to identify the particular species of mold and when you're doing viable sampling. Not typically your typical tool during a regular mold inspection. Aerosol. Cassettes. They're very popular. There's biocassettes, similar to the aerosol. These are registered trademarks. There's the Z5 sampling cassette, 5 liter by 5 minute air sampling cassette. Air sampling procedures, we talked about 10 minutes, but you have to refer to the manufacturer's recommendations. Z5 is 5 liters by 5 minutes. There's the pump. There's several different types of pumps. Here's mine with a little rotometer or rotometer. You can get your a battery that goes with your pump so that you can move around in an area. It's really, without plugging in, it's really handy when the house is vacant and there's no electricity. There's the wall sampling attachment. This is an aerosol inner wall sampler that you can you drill a hole very slowly, and or you can use a special tool that doesn't make a lot of dust and dirt. Stick the instrument in. This is an invasive, destructive instrument that takes air samples from a wall cavity. There are tape samples that are individually packaged and identified. There's a barcode here and a unique identification serial number for each tape and has its own mailer. And there are carpet cassettes, carpet instruments, sampling devices that can be used. And once it's collected, put it in a bag, ship it to be analyzed. So with all these sampling devices, refer to the IAC2 mold inspection sampling procedures. Let's go over do not sample for mold section. Do not sample for mold when a person occupying the building is under a physician's care for significant health effects attributed to mold exposure. A mold inspector should not be in conflict or dispute with any health professional by confirming or denying the absence or presence of mold and discussing the potential health impact from mold exposure. Consultation by a health expert should be recommended. Do not sample for mold when there is litigation being considered or in progress in relation to the mold in a building. The testimony of an expert should be recommended. Don't sample for mold when your health or safety are in danger. Do not sample for mold in a commercial or public building if you are a residential home inspector. IAQ specialists or experts in the field of commercial or public building inspections should be recommended, rather than a residential home inspector trained in performing mold inspections. Here's a general outline for performing a mold inspection. Number 1, scheduling an inspection is the first step to performing a successful mold inspection. When scheduling a mold inspection with a client, be sure they understand completely what services are available and in which inspection they are interested. Setting expectations It is very important when speaking to a potential client about your mold inspection services. Provide your clients readily available information about mold or your mold inspection services and any documents that relate to the inspection, including the IAC2 Mold Inspection Standards of Practice, your company's mold inspection agreement, and a sample mold inspection report. Having a company website with all pertinent information and downloadable documents related to the inspection service is a highly effective means of communication. Number 2, ask for the proper spelling of your client's name, their current address, and contact phone number and email address. Ask for the property address where the inspection will be performed. Set a date and time of the inspection. Request that the client attend the inspection. Get information about gaining access to the property, including the owner's name and contact information, and confirm the type of mold inspection that is being ordered by your client and the fee for the inspection. Number 3, prepare. Prepare all your inspection documents prior to the inspection, including filling in your client's information on all the documents. If the house is in the process of a real estate transaction, ask for any type of information disclosure document provided by the owner or the seller of the property. There are several computer software companies that provide inspectors the ability to create customized documents, templates, inspection checklists, and reports. Be sure to prepare the inspection agreement and a chain of custody document prior to arriving on site. Number 4, try to arrive at the inspection 15 minutes early. Meet, greet, show proper identification to anyone present. If the owner of the building is available, ask the following 7 questions. 1, are you aware of any active water penetration or intrusion at the building? 2, has there ever been any prior experiences with moisture or water problems in the building? 3, are you aware of any possible mold growth or mold in the building? 4, has the property ever been inspected or tested for mold growth before? 5, are any occupants in the building presently experiencing or have any occupants ever experienced their health affected by asthma, allergies, breathing problems, or mold growth? 6, are any occupants in the building under a physician's care for significant health effects attributed to mold exposure? And 7, is there any litigation being considered or in progress in relation to mold in the building? Number 5 step, a guide to performing a mold inspection. We haven't even gotten to the property yet, and into the building yet. When your client shows up, explain to your client what your inspection includes. A review, it should be. What is within and beyond the scope of a mold inspection. Review the inspection agreement. Allow plenty of time for your client to read and understand the agreement if they haven't done so already. We put our inspection agreement online so that they can download it after they schedule an inspection. Have your client sign the agreement and take the original and give your client the copy. Ask your client, step 6, ask your client about their concerns with the building and the apparent condition or conditions of its systems and components. Ask your client if they are aware of or suspect any conditions that have led to moisture intrusion, water damage, conditions conducive to mold growth, or the actual existence of mold growth, or musty odors. Develop hypotheses that can be answered by a visual examination and sampling. Now, number 7. Perform a non-invasive examination of the building. The building's visible, readily accessible systems and components should be inspected, evaluated, in accordance with the IAC2 Mold Inspection Standards of Practice. Document your examination utilizing notes, sketches, checklists, digital pictures, and computer software. Number 9, take mold samplings, air and or surface samplings, according to the IEC2 Mold Inspection Standards of Practice, and utilize the IEC2 Mold Sampling Decision Chart. So nice. Step 10. When you leave the building, make sure it's in the same condition as it was when you arrived. Pick up all the trash that may have come from using all of these mold collection devices. They come with all these wrappers and things that fall off. Number 11, at the end, thank your client and their agent if it's a real estate transaction. Thank everyone that's there for their patience, because it should take some time. Inform them of the average turnaround time of the laboratory results, and inform your client when your inspection report will be available. There are resources to go to have your client fetch your report online. Review all samples and identification numbers just before you leave, possibly in your truck. Make sure all samples are properly labeled, identified, and in your possession. Complete the chain of custody document for the laboratory. I don't move the truck until I'm done with all of that work. Don't do the chain of custody document while driving. Do it while you hit the stoplights. Step 13. Send the samples to the laboratory for analysis. Typically, this requires an overnight mailing. Step 14. Retrieve your laboratory analysis report. Usually it's downloadable or emailed to you. Prepare your inspection report for your client. The inspection report may include your letterhead, a description of the type of mold inspection that was performed, the scope of the mold inspection, a summary of the inspection written in simple language that your client can understand. The actual report from the laboratory should be included with your report. Any digital photos that were taken during the inspection, or at least the important ones, and the directions to attain additional information. And last, deliver the report to your client physically, electronically, ideally both, and then be available for questions and assistance. There will be questions.